For this demo, we will review aggregation in MapReduce, which will involve the processing of weblogs to calculate the total number of visits to websites. Let's begin the demo by opening the job. Next, I'm going to specify that this will be a MapReduce job. To have each mapper generate a subtotal of each block of records it receives, I'm going to update this task to be an aggregate. Within my source file dialog, I'm going to add the HDFS file that will be used for this aggregation, using the environment variable as defined under status. This file exists on a remote server, so I'll also need to specify the remote file connection that connects me to that server where this HDFS file exists, and that connection has already been predefined within this task. Now that I have my source in place, the next thing I like to do is to define my partition. And to do that, I'm going to create a derived field through the value button found in the toolbar. Let's start by giving it a name. Now I can define this partition any way I'd like. However, what's available to me is a list of functions that can help me create a correct balance of blocks of records that will go to each reducer. To make sure I have an equal distribution of records per reducer, I'm going to use one of the two hash functions. In this case, I'm going to use a crc32. For the crc32 function, I'm going to use the URL value as a means of partitioning my data, and in addition, I need to provide the number of available reducers. Now I can insert a static number of reducers I like to use for this job, or I can use an environment variable that will track the number of available reducers available at runtime, and that environment variable is dmxh Hadoop num reducers. Since each mapper receives a block of data, it makes sense to pre-aggregate the like records that may exist within a block. Normally, in most cases within Hadoop, you'll have more mappers than reducers. So take advantage of that and use the processing power of all the mappers that you have to pre-aggregate your data before sending it across the network, and you'll have less traffic going across the network to the reducers, and the reducers will have less work to do. For those of you that are familiar with MapReduce, you can think of this as the combiner step. So notice I can do it right here as part of my aggregation. There's no additional step that I need to insert or add. In this aggregate that's going to generate the subtotal by URL, I need to specify how I'm going to group by these records. And I'm going to use the partition value that I just set up. Then to get to count, I simply check this box. As data travels from the mapper to the reducer, it needs to be ordered by the partition value or the partition key. Now I don't need to insert a separate step or process to sort my data. I simply check that I want my output sorted by my group by value. Next, I'll add a target. Now this is just the mapper step, so it's not the final target. Instead, it will be the intermediate data file that is going to travel across the network. Also for this, I'll reference the intermediate data file by way of an environment variable. By default, our target will share the same layout or metadata as the source file. Now this intermediate data file that I just defined only needs a layout that requires just the fields necessary for the reducer. And to create that specific layout for this target, this intermediate data file, I'm going to add a reformat that will do that for me. And within this reformat target dialog, I can create a layout for my target that has a unique name. I can specify the file type, pick and choose the fields I want to have as part of my target, and also change the data type of those fields. Now that my mapper is finished, I'm going to add another task that will serve as my reducer. This task will also be an aggregate that's going to take all those mapper subtotals and give me a grand total for all the URLs. Now that intermediate data file that I defined in the mapper will serve as the source or the input for the reducer. Along with that intermediate data file is also going to need that reformat or the layout for that intermediate data file. Now, I don't need to recreate it. I can just simply pick up the metadata or link to that metadata that was defined within my mapper task by choosing this Link External Metadata button. In MapReduce, the output from the mapper needs to be the input to the reducer, so I'll add that intermediate data file here. Next, I'm going to calculate those grand totals. So let's go into this aggregate. So it can be safely assumed that all like records or all records with the same partition are on the same reducer. So I really don't need to group by the partition value like I did in the mapper. So the only thing I need to do is choose the URL, and then I'm going to take all those subtotals to give me a grand total of the URL. This isn't a MapReduce requirement for the target, but I'd like to see my URLs in alphabetical order, so I'm going to sort them. So I'm going to add a target for my URLs and grand totals, and it will be an HDFS file. I am also going to place that file on the remote server where my source exists by choosing the remote file connection. And again, I'm going to add a reformat because I don't need to have the partition values as part of my final output. I just want to see the URLs and also their final tally. So that was quick and painless. And now the fun part begins. I'm going to create a sequence between my mapper and reducer. The weblog aggregation is now complete. Now we can run the job.